Hi guys, and welcome to the video on equal matrices and their properties. So we're going to learn about using matrix equality to find variable elements within matrices. We're learning this because matrix equality can be used to solve systems of equations more efficiently. So if we have these skills now, we could particularly go back and use them in pre-calc or in a later class. And you know you're going to be successful when you can find any missing elements in a matrix if you know that they're equal. So, the equality of matrices, two matrices are equal if they have the exact same dimensions and the exact same corresponding elements are equal. So, in this case, I know A is equal to B since they're both 3 by 3s and they have the same elements. In this example, despite the fact that A and B have the exact same elements, 1, 2, 3, 4, 5, 6, they are not of the same dimensions, so unfortunately, they can never be equal matrices. So, the use of this equality. We can use the equality of matrices to solve for variables. So here, I am missing the values of x and y and z, but using matrix equality, I can find them. So, I'm going to take you through that example. Find the value of x, y, and z. So right now, I can say that this element equals this element. So I can say x plus 3 equals 6. So then an elementary algebra problem leads me to find that x equals negative 3. Next, I could say, I know that these are equal, so y equals negative 1. Okay, and that's completed. I'm going to redo my check mark. And then the last one, 5 equals 5. That kind of is my check to see, hey, I know these two matrices are equal since they both have at least one corresponding element. And then the last one I'm going to do is 4 equals z minus 3. So if I add 3 to both sides, I get that z equals 7. And that completes my matrix, my mini matrix equations. So, using the properties of matrix equality, find the values of A, B, C, D that make the matrix true. So, first and foremost, I'm going to check and say, hey, they're both this is a 3 by 2, and this is a 3 by 2. And I do know that 7 equals 7 in a corresponding spot, and negative 3 equals 3 in a corresponding spot. So now, all I really need to do is see what values I can figure out right away. I can say that this A is in the same spot as this 5, so I can say that A equals 5, and I can say that without a doubt. The next thing that I could do would be to calculate the value of B by using this right here and this. So I would say 2B, or not 2B, 6 equals 6. So B equals 3. Boom. And then I can use the B equals 3 expression in this expression up here equal to 1. So I could say B minus 2D equals 1. So then I can substitute what I know is B is equal to. So 3 minus 2D. So I'm going to take the goes here. Equals 1. So negative 2D equals negative 2 when I subtract 3 from both sides. So D equals positive 1. Okay, so I have D, B, and A, and I have to go back and find C. So I have this expression here that A plus C equals 4. And then I can go ahead and substitute this value of A that I know. I know that A equals 5. So 5 plus C equals 4. So then subtracting 5 from both sides, C equals negative 1. And there we go. I used my matrix equality properties, and I was able to find A, B, D, and then C, but I found them all. All right, what about if we have a scalar? So find the values of x, y, and z that make the matrices equivalent. So if we have a scalar, the first thing that we need to do is actually apply that scalar to everything in there. So we're going to take this matrix here, we're going to multiply it by 3. So when I do that, I get 12 is the first element, and that matches up here. So that matches up my two matrices. I get 3x. I have to distribute to all of this. So I get 3y plus 3, and then I get 21. And that's going to be equal to the matrix over here of 12, 18, 15, and then z plus 10. And then I can go ahead, so 12 and 12 equal each other, so I can go ahead and start writing any of these equations. So the first equation I can write as 3x equals 18. So with some elementary algebra skills, x equals 6, taken care of. Find y. I can write the expression 3y plus 3 equals 15. So doing some elementary subtraction and division, I get y equals, take away 3, take away 3. Y equals 12 divided by 3 is 4. Ching. And then I would have one last equation. 21 equals z plus 10. So subtracting 10 from both sides, z is going to be equal to 11. And that's how I would use a scalar to find the missing values in my matrix. So last but not least, what happens if all of the elements are missing? So in a situation where I have this blank matrix A, I have A11, A12, A21, and A22. So what I am going to do is take a look at what these equations are stating, and it would be A11 minus 2 equals 4. That is all of this, and this written out as an equation. So if I went ahead then and added 2 to both sides, I would say that A11 equals 6. So A11 is 6. Then I could do the same with A12. So I could say A12 is equal to, or excuse me, A12 not equal to, but A12 minus negative 1 equals 3. So remember that's A12 plus 1 equals 3. So A12 equals 2. So that's that's A12 done. And then moving on, A21 minus negative 5 equals negative 2. So I did this one, and this one. So then it's going to be the same thing as before. It's going to end up being A21 plus 5 equals negative 2. So subtracting 5 from both sides, A21 equals negative 7. And then finally the last one is A22 minus 6 equals 4. So this one, and this one in sequence. Using the signs. If it wasn't clear, guys, I'm using the signs that are between each matrix. So A22 minus this matrix's number equals this matrix's number to write my equations. So add 6 to both sides. So A22 has to equal 10. So 10. And I forgot to write the negative 7 over here. And that's it. So that's it for matrix equality, guys. Matrices are equal when their elements are exactly the same and they are the exact same dimensions. When two matrices are equal, and we're supposing that they're equal, we can use their properties of equality in order to find missing or variable elements. We can include scalars of these matrices like I did in 2 problems ago, and we can find entire missing matrices in equations by using this equality as well. That's it for this video, guys. Thanks for watching, and I'll see you in the next one.